Launch the live, guys. Yeah, perfect. Sorry for that. I really had an issue coming back.
No worries, don't worry, it happens.
Hello, everyone. We are back. Sorry for the connection issue for the 1 minute delay. We're back with Hywel Carver, founder and CEO of Skiller Rail, and we'll talk about developing your developers' development, how learning can have an impact, and why it sometimes doesn't. I hope you are doing well, Hywel.
I'm doing very well, thank you, Mehdi.
Yeah, can you
And
share your side with us?
yeah, here we go. Shall
Yeah,
I crack on? Shall I go?
yeah, perfect. The
Excellent,
stage is yours. Have fun.
excellent. Yeah, thanks, Mehdi. So I actually want to start with a question. I want you to think about the answer to this in your heads. When was the last time you learned to do something new? Maybe you used conditional breakpoints in your debugger for the first time and you really suddenly understood how powerful they were, or you finally worked out how to write a web app in Rust, or maybe you cracked documentation and you realized how to write effective documentation that was going to be easy to maintain. I want you to think about that moment. And specifically, I want to think about, when did you really learn that ability? When was the moment where you went from not being able to do it and then suddenly you were able to do it? When did you gain that ability? I'm going to answer that in this talk, and I'm also going to tell you how to create those moments of real learning for yourselves and for your teams. So I'm very passionate about learning. That includes software and writing code in a variety of languages, but also learning really affects lots of areas of my life. So I've been learning to be a CTO, and I ran these dinners in London for a few years before the pandemic to learn from other CTOs about how to lead technology organizations better. And then over the pandemic, I started a podcast called Primarily Context Based, which really had the same aim. It was a chance for me to talk with other CTOs and learn from them and become better as a CTO myself. I've been learning electronics for the last few years and building my own 8-bit computer, which one day will hopefully be capable of playing Pong. I like quizzes and have been on a few quiz shows on television, and that's a very specific and slightly unusual kind of learning, but I think it is still learning. I play the saxophone, I knit, and I've made this jumper back in the day, and those are things that I've enjoyed doing and enjoyed learning, even if I'd never made anything good with them. And in fact, I think this list is far from complete. There's everyday skills like driving that I've at some point had to learn, and I like to think I'm getting better at the more I do it. And I play a lot of board games, which are almost all about learning. You learn the rules, you learn how to play, and then hopefully eventually you learn how to be good at the game. I started thinking seriously about learning in 2015, and it was immediately clear to me that some kinds of learning were really easy for me to understand. So if you want to get better at quizzes, some of the kinds of learning you will do is flags. These are two fairly similar flags. They've got the same background colors, and if you want to be good at quizzes, you might go and learn them. The top one is the flag of Venezuela. It's got that rainbow of stars, and then below that, Ecuador. It's got the same yellow, blue, red striped background, and it's got this crest on with an eagle. And you might learn Colombia as well, which has a similar yellow, blue, red background. With learning for quizzes, learning things like flags, seeing them, reading about them can be enough to learn them. But it's more complicated than that for other kinds of learning. Have you ever had that experience where you read or heard about a new language or a library or some idea in programming or a concept and you think, oh, that makes complete sense. I've got it. Like you're reading the documentation about ownership in Rust and you think, this makes complete sense. I understand these rules. I know what to do with them. Or you watch a video about monads in Haskell and you think, yeah, completely understand this. This makes total sense to me. I fully understand monads back to front now. Or you read a book about blue-green deployment in Kubernetes and you think, yeah, I understand this. I'm going to go and use this in all of my Kubernetes apps that I'm working on now. And then you go and try and take those ideas and use them in your code, and you just can't. You're stuck. Something doesn't work. There was something missing. And you feel like this. Maybe you recognize this image. This is an image from a manual from IKEA. So when you buy your flat pack furniture, there'll be a manual with it that tells you how to put it together. And I think this image is so clever because whatever language you speak, there's no words here. There's nothing written down, but you still know the whole story. You can see something has been partially put together on the floor. Some bits are are put together, and then there's a person. I always think of it as a man because I am a man and I'm often in this situation. And so I see this person as myself holding a hammer, holding the manual, and he's got this big thought bubble with a question mark because he doesn't know what's going on, and his mouth is this kind of seagull shape because he's really got no idea, and he is completely stuck. He's read the instructions, he thinks he's ready to start building, and he can't. And this for me is the experience I feel when I go and read or learn about some new concept and try and apply it, and then I can't, and I'm stuck. And so I try things, and I think you may have experienced this as well. I try things, I ask for help, I go back to the book, to the video where I learned it from, I experiment, and then eventually something clicks and it all works. But that takes me back to the question I asked before. When did the learning here really happen? Clearly I got something from the book or the talk or the video or whatever it was that I had kind of learned that information from. But I didn't get everything from it. It wasn't enough for me to go and write that Rust code or for me to go and build that flat pack furniture. So clearly some of the learning is coming from doing. So then what's the difference between the kinds of learning in those two situations? That question actually led me down something of a rabbit hole, and I've been thinking about and researching about learning in technology for the last 6 years, and I think I finally have some answers. So this talk is going to be about some models that already exist that help, but not as much as I'd hoped that they would. A model that I find really helpful for thinking about learning, and then finally how you can really make learning effective, specifically in software, because that's my interest. So before I'd learned anything about learning theory, my starting point was to think about all the things that I had learned and what I'd been doing when I thought I had really learned them. And I spotted some patterns. Many of the things that I had learned were about learning by doing. So all four on the left, electronics, knitting, playing the saxophone, and writing code, those were things I had learned when I was really doing the activity. That was when everything had clicked. In the bottom right, quizzes, that was really about reading for me, watching videos, spending too much time on Wikipedia, and then being tested on it. I discovered I had learned the things that I had been reading about and heard about on the videos I was watching. And then learning to be a CTO by running dinners and running a podcast, that was really about learning where something had happened. There was an experience I'd had in the past, and then I'd had a chance to reflect on it and discuss it with other people. And the learning had happened then, after the experience, at the point of discussion, when I could appreciate the way decisions had been made and why a different team had made a decision differently and why that made sense for them and not for us. This felt like a really good start for me because I'd identified some patterns in my own learning. And it was around this point that I discovered this model that already exists called ICAP. ICAP is an acronym, and it stands for these four words. ICAP says that you get better outcomes the higher up this list you are. So if your learning is interactive, so it involves communication with other humans, then you will get better outcomes than constructive learning, which is learning that involves doing something, which will get better outcomes than active learning, which is learning where you are doing something but not really building things while learning. And active learning gets better outcomes than passive learning, which is learning where you're able to just essentially consume information. And this matches some of my experience. I was finding that I learned knitting and the saxophone better when I was trying to do something constructive with them. And I certainly improved more as a CTO through interactive learning over dinners and on my podcast by talking with other humans about what they'd been doing. But I'm not really convinced that you could play the saxophone at all if you've only ever learned passively. I can't imagine someone who's only ever learned the saxophone passively by consuming information about how to play the saxophone without ever having actually touched one. I can't imagine that person ever being good at the saxophone. On the other hand, if I show you these three flags that all have a yellow, blue, red background, one has stars in the shape of a rainbow, one has no extra motif, and one has a crest with an eagle on it, and I ask you to find Colombia, I think you probably can. Even if you didn't know those flags before, you probably now recognize all three of these flags. Venezuela, the one with that rainbow of stars, Ecuador, the one on the right with the crest with the eagle on top of it, and then Colombia is in the middle. Now, if you didn't know that, if you didn't know those flags before, and you were still able to recognize these now, then you've proven that just through exposure, just by me talking about these things, listening to some random man on the internet talking about flags, you've learned some knowledge that you didn't have before purely passively. And in fact, I didn't even show the flag of Colombia before, but you were still able, from what I'd said, to work out which one it was. So if I go back to that ICAP model, you didn't need to go higher up than passive learning to gain that knowledge and be able to use it effectively. The other levels simply didn't apply. You didn't need active learning, constructive learning, interactive learning. Passive learning was sufficient. But with playing the saxophone, passive learning gets you nowhere. You just can't play the saxophone unless you're doing something with the saxophone. So I don't think it's quite right that one of these methods is better than the others. I think some simply aren't relevant to different kinds of learning. And there's something missing from this model that would explain that. I think one thing we can conclude is that you can't learn doing things passively. And this was another big revelation I had. All the things that I had learned that felt like abilities had required me to do something in order to learn them properly. I'm going to come back to that point later. I just want to quickly talk about a very commonly believed learning model, which is the idea of learning styles. So if you're going to learn passively, you might be thinking, oh, well, I'm a visual learner, so I need to learn best by reading and viewing things. Or I'm an auditory learner, and I need to learn best by hearing things. Or I'm a kinesthetic learner. I need to learn best by doing things with my hands while learning. And this is a really widely believed idea. However, there's no evidence that it actually helps you learn better. People have subjective preferences. People prefer reading to hearing or hearing to reading, but they don't result in better learning outcomes. You don't learn better if we follow your preference. You just prefer it. And the Purview Center for Teaching and Learning at Yale said it like this: the overwhelming consensus among scholars is that no scientific evidence backs this matching hypothesis of learning styles. And so if you've come across that idea, it might seem helpful, but it doesn't actually help you learn. Let's move on to another model for learning. So this is a very widely used model. It's called Bloom's Taxonomy of Cognitive Learning. Excuse me. And it's really about learning outcomes. It says that there are 6 levels of learning outcome, and the higher up you go, the better the outcome. And so at the bottom level, knowing something, then understanding it, then being able to apply it, then being able to analyze with it, then being able to evaluate, and then be able to create and innovate using it. And to bring that to life a bit more, I want to use an example. Some of you will have come across the idea of a closure. A closure is a function which has access to its own lexical scope. I'm going to show you an example in older style JavaScript. This might not be weird. This might seem odd to you if you're not used to functional programming languages, but essentially we have a function here called counter. Counter has its own local scope inside that function, and it creates a variable called count initialized to 0, and it returns a function, which is possible in languages that have functions as first-class objects. It returns a function which adds 1 to the value of count and then returns the current value. So we can call counter to get a function. In this case, I'm calling it C1. If I call C1, it returns a 1. If I call it again, it returns a 2. If I call counter again and call the result C2, I now have a different counter, which when I call it will return 1, and it will count independently. If I call C1 again, though, it's been unaffected by C2, and it still returns 3 because it's carrying on the count from before. Now, if I apply Bloom's taxonomy to the idea of closures, at the bottom level, you might say, I know what a closure is. That would be the sort of bottom layer of learning outcome. The next layer up would be, I understand how a closure works. If you could apply, you could say, I could solve this using a closure. If you were able to analyze, you'd say, oh, look, she's written a closure in this code. And if you were going to evaluate, you might say, a closure was a good way to solve this problem. And if you were going to create and come up with new ideas, you would say, well, I haven't seen anyone do this before, but I think this problem is best solved by a closure inside another closure. The problem with this model that I see is it doesn't help me work out how to learn something. It doesn't tell me how to get higher up the model. It gives names to those levels of outcome. It doesn't tell me why I can read a book on TypeScript and then understand a concept, but I still can't create something new with it. So there's something missing from this model about the nature of learning and what it should enable, and about how to achieve each level of outcome. And so that leads me on to this new model, because I've done a lot of thinking about learning that I've seen and experienced, what's been effective and what hasn't. I've done quite a lot of reading and researching around this, and I've done training myself as well. And I want to give you a new model that I think is missing from this existing world of models that will help understand how to create good learning and to get the outcome you want. And it's called knowledge, skills, and wisdom. The idea here is that these are three components of learning, three categories of learnable, if you like, three categories of learnable information or thing. They build on each other, but we should expect different outcomes from each of them, and we should be trying to learn them in different ways. So at the bottom level, knowledge. Knowledge is fundamental, it's information, it's data, and it's facts. It's something that you could write down. Skills, on the other hand, are know-how, their ability. They're things that you're able to do often without thinking about them. It's the kind of learning where you'd have to write a set of instructions for someone to follow. And then wisdom. Wisdom is contextual judgment. It's understanding a situation and making a good decision for that situation, rather than applying the same thing everywhere. These ideas build on each other. So skills often rely on knowledge, and wisdom is typically used in how you apply your skills. I'm going to bring that to life with some examples. So firstly, in writing software, the kind of things that we have to know are syntax, APIs, concepts, rules, protocols that define the language that we are using and the way that we're allowed to write. But the skill is in solving a problem with code. It's in taking the problem that you need to solve and translating it into code that solves that problem and applying those concepts within your code. And wisdom in code is really about solving a problem in the best way, in the right way for the situation. If on Monday you're writing a 100-line script that you're going to run once, and then Tuesday you're contributing code to a 1 million-line web application, if you are wise, you will be writing those things in very different ways because the context of them is very different. And the same things apply, the same breakdown applies for playing the saxophone. To play the saxophone, you need to know which keys make each note. You need to know which notes are in each scale. And you need to have these skills of reading music and making music. And hopefully, if you're wise at playing the saxophone, you'll be able to play well or tastefully in a way that you like. And this model really helped me see the different patterns in my own learning, because the outcome that I wanted was completely related to the kind of learning, which was completely related to how I had learned it. When I wanted knowledge, I was able to get that through passive exposure, through reading Wikipedia and then being tested on it. If I wanted skills, I needed to do something. I needed to be creating to get to the create level of that Bloom's taxonomy. And if I wanted to make better contextual decisions as a leader in technology, then what I needed was wisdom. And that came from doing things and then having that comparison, that conversation with other people who were also solving the same kinds of problems. There's an interesting phenomenon here, which is that we spend a lot of time trying to convert wisdom into knowledge. Wisdom is very hard to share because it's contextual. So to understand why someone else made the decision they did, why they used Scrum instead of Kanban, or why they wrote that project in C# instead of Java, you really need to understand the full context they were working with, the skills of their team, their existing technology in use in the company, the way they were deploying. And so it's very difficult for us to teach wisdom. It's often drawn from experience and time, and then reflection or comparison based on that experience. And so we as humans have come up with loads of ways of converting our wisdom into knowledge. Rules of thumb and heuristics, principles, standards, guidelines, best practices are all ways of taking wisdom that one or multiple people have gained and then trying to convert it into a form that can be easily learned by other people. I'm conscious that in this talk, I'm trying to do the same thing. I've spent a lot of time trying to become wiser about learning, and I'm converting it into a talk. And so please be aware that I'm aware that what I'm giving you is definitely knowledge rather than anything more than that. If I put it all together and compare those models, I can put the knowledge, skills, and wisdom model now on top of Bloom's taxonomy. And now you can link the way that you learn to the outcomes. You can learn knowledge passively, and what that will give you is the ability to know or understand something new, like the flags of some countries in South America. But it can't give you skills. You can't apply or analyze with those. To learn those, you need to do something different more than passive learning, which I'm going to come back to later on. But this answers my question. When our training fails, when we read the book and then wonder why we can't apply, when we look at the manual and then we can't immediately go and build the flat pack furniture, it's because the outcome we wanted was an ability. We wanted a skill. We wanted to be able to write code or analyze a situation or build a wardrobe. But the way we try and learn it is turning to books, videos, masterclasses, talks. We use passive learning to try and learn skills, and you can't learn a skill that way. And that means you can't enable the skill-based outcomes of applying and analyzing. Now, knowledge is relatively cheap. Generally, knowledge is very easily accessed by searching on Google or on Stack Overflow or on Confluence or looking in your documentation. It's only occasionally that we need a local cache of knowledge in our heads. Most of the time, we can just look it up quite quickly online. Wisdom is also only needed relatively occasionally. We need wisdom when we're thinking about big design decisions that are going to be hard to change later. Skills are what we're using all day, every day in writing software and in working in our teams. So skills are very valuable to us. The problem is that passive learning, that gives you the fundamental knowledge, right? It tells you the basis of knowledge that you need when applying the skill. But it's only when you go to try and use that knowledge that you're actually applying it. And then that's when you start learning the skill. That's when you start getting the ability to do something. Which is why we all have that moment when we realize the understanding we got from the video, the book, the blog post is not enough on its own. And we get stuck and we have to do something different in order to learn the skill. I think the obvious question then is, how do you train for skills? Or to put it another way, how do you become capable of something new? And for people who are leading teams, how do you help others around you to become capable of something new? Well, remember, skills come through doing. You learn the saxophone by playing the saxophone. Reading, watching, listening can all help you play. They can all feed into that, but you need to play in order to learn. And when you're playing, you'll make mistakes. You'll play the wrong note sometimes, you'll fail, but then you practice and you improve. And it's the same in software. You learn to write software in TypeScript by writing software in TypeScript. You'll make mistakes along the way. You'll hopefully be able to debug them, and then you improve. And skill learning always follows that same pattern. I tried to write this down, and it seemed very basic. So to try and compensate for that fact, I've written it as an algorithm in BASIC. The general program for learning a skill is a loop where we try. If we fail, we try and get feedback to improve what we do next time. And then we go around the loop again and repeat. Now, if we learn passively, then we get the knowledge that's needed, but not the skill. That's because passive learning doesn't give you the opportunity to fail. That might sound counterintuitive, that failure is an opportunity, but it is. It's in our failures that we learn and improve. Without that feedback that lets us improve, we can't get better at a skill. So if you learn about Kubernetes from a book or a lecture or a video, you can learn the principles and ideas behind it and the syntax for it. But when you come to try and do the skill, that's when you start, that's when you enter this loop of feedback and failure and therefore learning of a skill. Now, if you're learning on your own as a side project, your feedback will typically come from the error message and from then trying to work things out for yourself. So your feedback in a side project can come from Google and Stack Overflow and the documentation, or going back to the book and rereading about the topic that you wanted to learn. And you can learn the skill that way. It's just quite slow. But that's option one. the first way to learn a skill is you throw yourself at a problem, you throw your time at a problem, and you can run side projects and learn by iteratively trying to fix your failures along the way. There's a variant of this, which is learning on the job, which is the same process, but now feedback comes from your co-workers as well as from Google and from Stack Overflow. There is a second option, which we call targeted capability training. It's a way of learning skills very effectively that people generally love. The way you start is you look across a topic. You try and understand exactly what someone, maybe yourself, maybe someone on your team, can already do and what they can't. And that lets you focus learning on what's new to someone and what's useful to them. Then for each of those individualized skill gaps, you can train for skills. I think this is really important because it avoids boredom. It makes sure that learning is relevant to what someone needs to know and what you want to learn. And it's a way of ensuring that learning is learning, that we're not spending time on things that you already know, because there is nothing worse than boredom for getting in the way of learning. I think learning is always interesting and always exciting. And if you're bored by something, you're probably not learning anything. When that learning happens, it should be centered on solving problems hands-on, led by a trainer. And that's really important because with the trainer there, the loop for learning a skill becomes much, much tighter because the feedback can be immediate. If you are trying and failing and getting feedback on your own, it can easily be, well, in my experience, it's sometimes a day between causing an error and then working out what actually went wrong. With a trainer, that feedback can be a matter of seconds, maybe minutes at the most, so that your speed of learning, your speed around that iterative loop can be very, very fast. And this is the most effective way I found to learn new skills quickly. The core of the idea is that you personalize everything. You only teach people exactly what they need to know. That means it's relevant to them and you're not telling them things that they already know. So you're not wasting anyone's time through learning. Secondly, it should all be hands-on, because if you want to learn a skill, you have to learn by doing. You need challenges. To make that learning efficient, you need an expert to lead the learning. The most efficient feedback loop is a human who can watch you as you learn, give you that feedback, answer questions, debug your understanding as well as your code, and then give this really quick skill growth by making a very fast feedback loop. And lastly, I suggest doing 1 hour at a time. This has two benefits. If your learning is broken into those modules of that size, then that creates your unit of personalization. Each hour can have someone in or not, depending on whether that topic is something that they need to learn. And it means people can learn in the flow of work. You don't have to leave your desk even to learn. You get a chance to solidify each small unit of learning before learning something new, if the learning is happening 1 hour at a time. I think there's a really interesting balance here as well between hands-on and expert-led, because a lot of learning forces you to swing between the two. An expert might write a huge book or a series of talks or courses or videos, and then the learner spends time reading and consuming those, and then fully switches to being hands-on, completely separate from the expert for a long time. If you want effective learning, you can bring those things together really tightly so that the learner is hands-on with an expert present. And if you tighten that feedback loop at the center of learning a skill, you gain the skill very quickly and effectively. We actually built our company around this idea because this is how we train at Skiller Whale, but you're very welcome to copy our methodology, which is why I outline it in detail in this presentation. We see our job as helping CTOs upgrade the skill sets of their software teams. And crucially, we know that this methodology works and people like it, because our learners give our way of training a score of 4.8 out of 5. And our customers tell us that it's for bringing skills into a team, it's 6 times cheaper than hiring and outsourcing, and it can have a measurable impact on your velocity and quality. I hope this talk has been very useful. I'm very happy to answer any questions that you have as well. And yeah, you feel free to hit me up on Twitter or on email here.
So we have a few questions about like the skills, the skill aspect. So we don't have direct question from the audience right now. So I invite people to ask a question directly on the Q&A session. So I will start maybe with one question. Can all skills can be learned by developers? We've tried to make security learned by developers. We've tried like ops making learned by developers, documentation previously by developers. Soon it will be privacy regulation, whatever. Can everything should be learned on the on the developer persona?
That's a really good question, and I think you have to separate. I'm going to pick on security because it's the one that stuck in my mind when you were saying it, Mehdi. Um, I think much of security thinking isn't skill; it's wisdom. To be good at security, you need to look at a situation, a setup, and say, "Well, hang on, there's a problem here that I can anticipate." You need a very holistic view to be good at security. Um, I can't think of a good example off the top of my head. If we're exposing this information via our API and someone else could copy that string readily and then have full access um, to a code base or to our data store, for example, then it's that kind of stepping back and looking holistically that I think is the wisdom of security. I think there are specific skills that we can teach people, and there's specific knowledge we can give all developers. So I think all developers should know how a SQL injection attack would work. I think all developers should know what cross-site scripting is, and I think they should have the skills to be able to defend against those things. But security, I think, is a broader topic than just isolated individual bits of knowledge because it's ever increasing.
Yeah, I
Does
really
that
love
answer?
the I really love the wisdom, skills, and no, yeah, difference. Recently, I've seen like no code developers, like no companies investing a lot in no code, but they are able to build stuff, but they don't have the wisdom. So they don't understand security, they don't understand access management, they don't understand this stuff, and so it's a nightmare. So wisdom is as much important as skills. I agree with you. We have a question from Rakto. What would you suggest for the case of mentoring? Should a candidate start with gathering knowledge, then skills, then apparently getting some wisdom of it, or these things should overlap somehow?
I think it depends what you're mentoring on. So in my experience, mentoring as opposed to coaching, I think of mentoring as someone brings questions, and coaching is much more I bring guidance for what they should be learning. And it's going to depend on what you're trying to mentor them in, honestly. So if you're thinking about, let's say you're thinking about, I want this person to be better at using this library. There might be knowledge aspects of that, um, and there might be skill aspects of that. I think wisdom is quite a hard thing to teach. So with knowledge, let's say you want to make sure someone knows the APIs for the library, you can kind of talk through some of the APIs that you think are useful and interesting, and then make sure that they go and apply those. I think the skill would be having conversations about when to use each of those things. What do you expect to happen if we call this API method, then this one, then that one? What will happen in this situation? And wisdom typically, I think, can come from the review process. So typically in a kind of pull request review situation is a good chance to look at the way someone solved a problem, the skill they've applied, and say, actually, I think we should apply it in a different way. It looks like you're specifically thinking about newcomers into a company or interns, and generally, I think there's a lot of knowledge when you're onboarding new people. So typically, when you bring people into a company, you need to make sure that they know the coding guidelines, and they need to know their way around the office, all of those things that are just kind of core to working at the company. I think it's later then when you can start thinking about the skills of work that you need them to have. But often onboarding is really knowledge focused. We focus a lot of our time when hiring people on skills. And for senior roles, we look at their wisdom as well. I think when you're onboarding people, they should have similar skills to what you need. And just getting them up to speed in the company is often more about knowledge.
Yeah, it's an excellent timing. We have a 20-second with the audience. But when you were talking about educating of newcomers, exactly, Radko was exactly asking this question. So I think you answered both in the same time. We have a point on Lawrence. He said, who says like interesting point on how we try to convert wisdom into knowledge. It's someone remind me of the saying, sitting on the shoulder of giants. It seems the previous generation has made a lot of insightful findings that we today learn as a basic knowledge and everything, right? And so, would you say that such conversion of wisdom into knowledge is what drive advancements in different fields?
Yeah, that's a really excellent point, Lawrence. And I like the amount of thinking you've done about that. That phrase, "sitting on the shoulders of giants," that was Isaac Newton, I think, talking about his formulation of the rules of gravity. And he said, "If I've seen further than those who came before me, it's because I was sitting on the shoulders of giants." I think in that quote, Newton is talking about knowledge. He's talking about other people who've done investigations into physics, who've come up with laws and formulae and written them down for him to then learn and then build on. I think the wisdom is not so much in the laws themselves, but in the ability to formulate them. So there is a skill of scientific investigation, and there is wisdom around how you use that skill as well. And when we apply that skill, we can generate knowledge, and it's that knowledge that we record. So, to translate what Newton's saying into like software language, software coding kind of terms, if Newton was able to build this incredible feature in our application, it's only because the Confluence documentation and the existing APIs and the existing software that existed made it easier for him to do so, if that makes sense. So converting wisdom into knowledge is definitely useful, but actually, in the case of that quote, what's being built on is the knowledge itself.
Yeah, do you agree with this Confucius quote? By three methods we may learn wisdom. First by reflection, which is the noblest, second by imitation, which is the easiest, and third by experience, which is the bitterest.
I haven't come across that one. I like it. I don't. I'm not sure. So I'm nervous of translations as well, by the way, because it's totally possible that the original quote was didn't quite mean wisdom. I've seen similar things where people talk about Aristotle writing about skills and wisdom, and actually he's using those words in quite different ways. I think reflection is definitely a great way to learn wisdom. As a CTO, I've seen in this situation, I applied these ideas and they were a terrible idea in this other situation. And then I realized why, and then I learn when those ideas made sense, and that helps me improve my contextual judgment. So yes, I definitely see reflection. I think imitation is not necessarily wisdom. I think at that point, you are using a skill to apply someone else's knowledge. Someone else has done something. They have found a way of translating that to you in the form of knowledge, and then you have applied it. I don't think you are learning wisdom when you do that. And then experience, I think experience goes with reflection, at least in my definition of wisdom. You need to have experience and then reflect on it in order to gain wisdom. I don't think you can really get wisdom without that experience.
We have a question from Inta, like how can you determine what skills you or your teammates might need to develop? And she says, if it's something not task related.
Yeah, that's a good question. So I would say the way to do that is to think about the things that you need for your job. Is it communication? Is it deep technical skills? Is it security awareness? And then break those down. So if I go back a few slides, let's see. This is actually an example breakdown for what is this? This looks like Python. So this is part of our internal breakdown for Python skills, where we look across the language as a whole and work out whether each individual part of it is something that each individual in the company knows and can do, or doesn't know and can't do. And so if you do that breakdown and then can assess either through questioning or through your kind of sense of what your teammates can do, then I think you can become very targeted in those areas where skills are needed.
Yeah, we're waiting for more question from the audience, but yeah, so far it's really like a really good talk on like separating the wisdom, the skills, and the knowledge, right? Because there's a lot of confusion in teams and in management about like which one is more important for what type of role or job or let's say specific position. So yeah, definitely.
Hmm. I think that's right, and I think your question actually reminded me of another model that I've come across, and I don't include in this talk. Um, it was taught to me by a jazz trumpeter. I think he got it from another jazz guitarist, and the model is imitate, assimilate, innovate. Which for people whose first language isn't English, it might be unusual words. Imitate essentially means copy. Assimilate is like make it your own and internalize it so you can do something without thinking. And then innovate means kind of create something new and generate your own ideas beyond that. And I think there's something about the sort of transition from skills to wisdom there, that when you are imitating and starting to assimilate, really you're learning a skill. It's also used in the martial art of, I think it's Jitsu or Aikido. I can't remember which one, but in one of the martial arts, they have this model of Shu, Ha, and Ri, which really is their I think they're Japanese words that talk about the progression from being a very new martial artist to being the master. And it's the same kind of thinking that we can initially learn those skills by copying others, and initially learn, I guess, that wisdom by copying others, and then we can internalize it, and then we can see beyond it and create our own ideas beyond that.
I would just ask. We have 3 minutes and no more question directly. Maybe one question about where we can find your podcast.
Well, yeah, it looks like it's not on iTunes, which I didn't know about. So most, as far as I was aware, it's on most podcast systems. It's called primarily context based. It's kind of a play on Stack Overflow, because on Stack Overflow they close questions as being primarily opinion based, and I think primarily context based questions are actually the ones with the most interesting answers. So if you look on a different podcast reader, I think you will find it. I tell you what, if you follow me on Twitter, I will tweet a link to it on a variety of podcast places shortly after this talk.
So you have a reward if we follow you. Yeah, well, perfect. So
Exactly,
one
that's my
question
handle.
about knowledge. Sometimes they have a question like, does more knowledge kills creativity or ingenuity? What I'm saying that it was a book called the Imaginary Museum, and someone was saying like Michelangelo or many artists they've never seen museum before. You know, it takes you 2 months to travel from Milan to Paris or stuff like that. Actually, a lot of creators didn't have all the knowledge of the world before actually creating, having some naivety, naivete, all right, being able to finally create something and be smart and get rid of all the knowledge they need to know. So how do you find the right balance between pushing more knowledge to people but also letting them like maybe create their own knowledge and challenge the status quo?
I love that question. So I guess the first thing to say is that Michelangelo lived like 500 years ago, and we still know his name. And so we probably shouldn't use him as a model, because he was clearly a one-off, and there aren't many other people like him. I don't think knowledge stifles creativity. I think only teaching knowledge stifles creativity. I think you need to give people knowledge and give them room to express. Right? It's that same thing of imitate, assimilate, and innovate. If we never let people get to innovating, then they won't have creativity, because they won't have a chance to practice it. I think on the other hand, if you think about that Newton quote about standing on the shoulders of giants, at least for him, it was really clear that he was building on what other people had done. Um, so I suspect Michelangelo maybe hadn't traveled so far, but did see sculptors of the time, and was building on what they could do. Or maybe not. Maybe he was just a real one-off genius. But most of us aren't Michelangelo, unfortunately.
We have 30 seconds, and the last question from David asks, as a universal personality, how handy do you find your broad knowledge of other areas that are not connected to software engineering? Does it have a strong impact daily in a professional environment?
I don't think it does, honestly. I like having a broad knowledge of other areas just because it interests me, but I'm not sure it affects my software engineering at all. I think what does affect it is the being able to learn fast. That is a generally useful skill, and it's kind of at the core of our company, honestly, and therefore at the core of my work.
Yeah, at least if I just can make a comment, but I've seen a lot of architects and a lot of great software developers who also do music. I don't know if it has
Mm,
a sense or a link or correlation. It's not causation but correlation. But yeah, I've seen a lot of people who are really good at music and who are also like recognized as great developers. I don't know if there's a correlation or
interesting.
causation, but it translates.
Yeah,
Thank
that is
you.
interesting.
Thank you very, very much, Howell. It was a great talk, a lot of questions. Yes, and yeah, again, you can follow Howell on Twitter and reach him directly on skillerwhale.com. Yeah, we will go for the break, and we'll be back. We'll be back later for continuing this brilliant Teams track at Dev Days Europe. Thank you.
Bye.
Bye, everyone. And yeah, let's hope this afternoon we'll have as good talks as we had this morning. I think it's yeah, so far the attendees are happy. See you.
See you.